So just as a reminder, correlation is when you wanted to see the relation between two numeric or two ordinal variables, and you usually judge it on a scatter plot. You have the x-axis and you have the y-axis. The degree or the magnitude of change in y with each change in x, this measures the correlation. So if x increases and y also increases, we call this positive correlation. If x increases by 1, y also increases by 1, we call it perfect positive correlation. This is perfect. Sometimes the line is a little bit slanted, okay? It's not exactly 45 degrees, so this is a weaker positive correlation. And if the line between the points is horizontal, this is no correlation. Again, correlation might be negative. So when x increases, y decreases. This is perfect negative correlation. With a correlation coefficient, here the correlation coefficient, we call it R, it equals 1. Here the correlation coefficient R equals -1. So this is a negative perfect correlation. Sometimes correlation is negative, but it's weaker. Okay, so usually statistically, we test this by something called Pearson correlation. And if these values are not are numeric, but they are not normally distributed values, they are more or less ordinal values, we use Spearman correlation. This when we are trying to statistically assess for the correlation between x and y. I'm saying all this as a reminder and also to say using Pearson and Spearman correlations are not the correct methods when you are trying to quantify stability, when you are trying to assess the stability between raters at two different time points, when you are repeating the same test on the same population at two different points, or when you are comparing results from two observers on a numeric measure, Pearson and Spearman correlation are not the correct ways of doing this. Instead, we have a method. Those who are acquainted with SPSS, these are the steps. They go to something called analysis. Let me see if I can open. A database now that we can use just for demonstration of these measures. Okay, here we are. It's going to open. I'm going to show you. Let me see if I have this caravan data. I hope I have it. Yes, I have some of the caravan data. Okay, so we have the questions here that we asked in the caravan. Like, for example, information was given to me early enough. I was adequately informed about my rights. Now, let's just imagine that these are not two different questions. Let's imagine that these are two incidents when we ask the same question to the same people on two different occasions. So we are going to imagine, we're just going to use the numbers, okay? We have two sets of numbers, okay? The first column here, okay, it is when we administered the question for the first time. And the second column here is when we administered the same question for a second time. Now, as you can see, these numbers, they mean responses. Like, for example, any 4, it means agree. 5 means strongly agree. 3 means neutral. 2 means disagree, and 1 means strongly disagree. This is what we call the Likert scale. So this is these are the responses, and this is how they are coded. Because when we are doing statistics, we always want to convert responses to numeric codes. So now we have numeric codes for these responses. We decided to say, okay, if we get an answer of strongly disagree, we give it 1, disagree, we give it 2, neutral, we give it 3, agree, we give it 4, strongly agree, we give it 5. That's how we converted answers to the questions to numbers. And this is what we call the Likert scale. So this is a 5 response Likert scale. And again, I am imagining that I am giving the same question twice. So let's see how to assess for stability of this question. We're going to analyze scale reliability analysis. Here, we go to the statistics and we want to do intra-class correlation coefficient. Type. What are we aiming for with intra-class correlation coefficient? We have this, we need to see this menu. Do we need to demonstrate consistency or absolute agreement? With consistency, we're doing something very similar to the Pearson and the Spearman correlation, where we want to ask or to see whether X correlates with Y. But this is not good enough for us now, because as I said, we imagine that we have given the same question to the same population twice, to the same people twice. So each time we are going to administer the same question to person X or to person whoever, we expect different or the same result? Different or the same result?
Same.
The same result. That's why we need to find absolute agreement. And we say continue. And we choose the 2 questions on the Likert scale. Now, again, we imagine that these 2 questions, they are the same question on 2 different occasions, and we say, okay. Now, so here we want to see the intra-class correlation by this figure here. As you can see, single measures intra-class correlation, it's 0.164. This is very bad. This is very bad. Why is this very bad? Because we want it to be, as you will see, we are aiming for intra-class correlation coefficient of something which is more than 0.7 type. How can we get something like this? Let me do some changes in the data. Maybe I'm going to insert a new variable here, and I'm going to copy exactly this one here. And I'm going to do some very minor changes, like I'm going to change this to a 5, and change this to a 2, and change this to a 3, just to get some changes. And perhaps change these to 4s. Some changes, so they are not exactly the same. And I'm going to name this question 1 again. So now I can imagine that I have given question 1 twice to the same set of people. And I'm going to repeat my analysis to get the intra-class correlation. So I'm going to go to scale, reliability. I'm going to remove this one and take this one. Do we have it here? Yeah. I don't know where the variable is. This is question 1 again. Let me see. Again, it's numeric. It should be there. So it's 1 and 1 again. Okay, I'll see. Analyze. Reliability. Scale reliability analysis. Yes. Don't know why I can't find it. Why is it not there? Yeah, it's the 2 of them now. I'm going to say okay, because now it has the same criteria as I've chosen before. I'm going to say okay. Can you see now the single measure intra-class correlation now? It's 0.8. If I am going to construct a scatter plot now, I'm going to say graphs. Okay, I'm going to demonstrate a scatter dot. And here, let me take these two y-axis on the x-axis. I'm going to show you this. Because the Likert scale is not very variable, but if I'm going to find fit line, see how nice the fit line is? It's very nice. What about questions 1 and 2? So I'm going to construct a scatter dot with questions 1 and 2. I'm going to kick this out and take 2 instead. And say okay. Now I'm going to see the fit line. Can you see the difference between the fit lines? Can you see the difference between this fit line? It's almost 45 degrees. This fit line is more horizontal. Why? Because correlation here is weaker between the two questions. However, because this is the same question repeated with only slight differences in the responses, you see very nice correlation here. And if you are going to formally assess the intra-class correlation, you're going to find this 0.8, okay, in contrast to 0.164. Okay, so you get it now? Now you know about intra-class correlation and how to assess for it? Is that okay? Yes. So for the test-retest reliability, this tends to reduce when the test reapplication is extended. So the longer the interval, the less will be the correlation, or the less will be the intra-class correlation. The time span between measurements would influence the interpretation of reliability in test-retest. Therefore, the time span is from 10 to 14 days. This is considered adequate. And with regard to your sample, if you are checking really a questionnaire and you want to find its stability, which is a form of reliability, you're going to administer it twice to the same set of people. You need to space it 10 days apart, and you need to have at least 50 subjects to consider this adequate. And we're looking for a minimum value of 0.7 for the intra-class correlation coefficient. So you get this now? Okay. Now we shift to the most famous measure of reliability, which is the internal consistency. You cannot publish any study on a questionnaire without calculating what we call the Cronbach's alpha. Cronbach's alpha is a measure of internal consistency. And again, it is more or less a correlation coefficient, but it's the way that this correlation coefficient is calculated, it is slightly different, so it means something else. Now, this internal consistency, it's not about repeating the questionnaire. It's about the relation between the questions within different parts of the questionnaire. So let's go back to the Hajj Caravan questionnaire. Here I have the list of questions. Okay. Yeah. Information was given to me early enough. I was adequately informed about my rights. I thought I could take one of my relatives with me. I was not informed about my risks. I had enough help from nurses in bathing, wearing ihram, and serving lunch. What can you notice here with the first 4 questions and with the question number 5? Any notes here? What did you notice? First 4 questions were about information given. So they are measuring more or less the same thing. Now we move to question number 5. It's asking about the help given for nurses. Number 6, I was escorted safely by staff security. Assembly area was crowded. The bus area was well controlled. So it's moving us from the information to the actual help that was given to the patients and then to about safety measures within the caravan assembly area. Okay, so you can see that different sections or domains in the same questionnaire, they have different subjects or they measure different things. But again, the whole questionnaire is all about satisfaction in the Hajj caravan. So again, this questionnaire is like a big something that is divided into subdomains, and all the subdomains are measuring one big thing with the satisfaction and experience during Hajj caravan. Right, let me ask you something. Concentrate on the first 4 questions. If information was given in a good way, how would you think the 4 questions will vary? Will they all move in the same direction? Or is it likely that I'm going to give good answer for question number 1 and bad answer for question number 2? What do you think? The first 4 questions asking about information, different aspects of information given. So if this information given to people going on this trip was given in a good way, what do you think about the relation of these questions to each other? Will they all move more or less in the same direction or in different directions?
More or less in the same direction.
More or less in the same direction. So these 4 questions, they should more or less converge, okay, on one thing. Okay, so this is the aspect of reliability that's called internal consistency. Okay, so the items should all of them tell us more or less the same thing. They cannot be totally divergent. Okay, they tend to move with each other. Okay, especially when you measure responses from different people. So it is this correlation between the different items in a questionnaire that it's called internal consistency, and it's measured by something called Cronbach's alpha. Now, we can measure this in a very simple way, more or less like we did before, but here we're going to concentrate on something else. Here we go to, let's say, scale reliability. This time, we're not interested in intra-class correlation, so we're going to totally reset the system. Okay, I'm going to show you a trick. Some of these questions were positive and some of these questions were negative. Okay, some questions were asking about good things and some were asking about bad things. So the questions that tended to have negative answers, they had to be reversed. Like if you agree with something bad, okay, this is bad. Okay, so if you strongly agree with something bad and you give a 5, this 5 needs to be converted to 1. Okay, this is called the reversal. So we have these reversed questions: 3, 4, 7, 13, 14, 20, 26. Too many numbers. I'm going to put them here first. And perhaps we're going to leave them out from the main questions. Okay, so we already have 3, so we take 1 and we take 2, and then we have 3 and 4, so we take 5 and we take 6. Okay, and then we have 7, we take 8, 9, 10, 11, 12. We have 13 reversed because it's negative question. Then we have from 15 to 20. So we take 15, 16, 17, 18, 19. Okay, this is enough. I'm not going to take the whole questionnaire. I'm not reanalyzing the study. Now I'm going to, here, it's going to give me the most basic measure or the most basic statistic that I need, which is called the Cronbach's alpha. This is what I need. Okay, but I will do some statistics, some more statistics, something called scale if item deleted. Continue. Okay. I'm going to look into Cronbach's alpha. Cronbach's alpha is 0.72. 0.72, which means the measure of correlation among all those items. This whole list, almost maybe something 20 something items. Okay, their internal consistency is quantified, their correlation among each other is quantified by 0.7 with a maximum of 1. So this 0.7 is nice, it's not that bad. Okay, but I can make it better. I can make it better. So how can I make it better? I look into this. It says Cronbach's alpha if item deleted. Here, the program is telling me that with each of these items, what would be Cronbach's alpha or correlation coefficient, okay, of reliability if I'm going to delete this item. So if I'm going to delete item number 3, my alpha is going to decrease. It's going to be 0.691. This is not good. I want my alpha to be higher. I want the questionnaire to be more consistent, to be more reliable, to have more internal consistency. So if I'm going to delete number 4, my Cronbach's alpha is going to be higher, so I can delete number 4. Okay? And again, if I'm going to delete numbers 38 and 1, maybe it's going to slightly increase. Okay, so let's now repeat the same analysis. Analyze, scale, reliability, and look for number 4. Was it 4? And what else did we want to remove? Numbers, what? Which ones did we want to remove? Number 4, okay, and numbers 38 and 1. So maybe I'm going to remove number 38 and I'm going to remove number 1. And I'm going to say, okay, now. See, my Cronbach's alpha is now increasing. Okay, what does this mean? It means that these 3 questions were not that perfect. I need to revisit these 3 questions. I need to have another look. If I think these 3 questions, maybe 1 or 2 of them are still very important to my questionnaire, I can keep them. But if I think that these 2 questions or these 3 questions or maybe 1 or 2 or the 3 of them are not that important, they are decreasing my Cronbach's alpha, they are decreasing my internal consistency, I can get rid of them. Okay, so here I'm going to repeat the cycle again because my Cronbach's alpha now is 0.756. Okay, but if I'm going to delete number 26, it's going to increase. Okay, and again, if I'm going to delete number 5, it is going to increase again. So perhaps I invent a questionnaire, I give it in a study, I perform reliability on it, and then at the end of the study, I end up and say, okay, these items can better be deleted and the questionnaire is going to be more reliable. Then perhaps someone else, or perhaps I do it myself and I repeat the same or the modified questionnaire in a new stage or in a new study, a new stage of the same study or in a new study on a different, on the same population and see how it does with reliability. So, can you understand? Okay. Do you get this about reliability? So you know what internal consistency is? Huh? So internal consistency or homogeneity shows if all subparts of an instrument measure the same characteristic. Okay. For example, if an instrument that assesses individual satisfaction with job has 9 domains, all items of the domain of salary are supposed to measure this construct, okay, about salary. not a different construct such as benefits. So I'm going to include salary questions in the benefits domain. The benefits domain is not going to have good internal consistency. This is an important measure property for instruments that assesses a single construct using for this a variety of items. So a variety of questions to measure the same domain or the same aspect of something. An estimate of low internal consistency may indicate that the items measure different constructs or that the answers to the questions of instrument are inconsistent. So it may be about the question or about the people who are answering the question. So most researchers assess this internal consistency by Cronbach's alpha, the one we just calculated. Cronbach's alpha demonstrates the covariance level between the items of the scale, how they covary with each other. It is more or less like a correlation coefficient, but it's calculated in a different way to show us something called covariance between the items. The lower the sum of the variance, the more consistent the instrument will be. Cronbach's alpha is the most used. There is to assess internal consistency. There is no consensus about its guidelines. Okay, some studies say that values higher than 0.7 are ideal. Some consider that values under 0.7 or even 0.6 as satisfactory. So you are looking for a higher Cronbach's alpha anyway. Okay. So a number of items, they influence this Cronbach's alpha. The number of items per domain of an instrument may reduce alpha's values. If there's small number of items, if only we have 3 questions, 4 questions, we might get a low alpha. Okay. And again, it's talking about alpha if item deleted. To show us which items are doing us bad and we can get rid of them to have a more a questionnaire with better internal consistency. Okay, so values of alpha if item deleted allow the researchers to evaluate if one item is removed from a certain domain or tool, the value of the total Cronbach's alpha, whether it increases or decreases. Okay. 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 We measure something else, which is called the average correlation between the items of a questionnaire. Okay. Here also we measure this. We assess it by SPSS. Okay. But I'm not going to go through this because I think this is enough for you. Now we talk about something called equivalence. Okay. Equivalence, it's again about inter-observer variability. When the observers, they judge something on a dichotomous scale, whether it's positive or negative. We use something called kappa coefficient. I explained that before. But sometimes the evaluation of the raters or the readers or the questionnaire is numeric. Okay. In which case we're going to use something like intra-class correlation. So when you're going, when you administer the questionnaire and you have your results, what do you do? First of all, just as a sum up, let's say you want to now perform a study using a questionnaire. This is a very, very, very good idea for students and for undergraduates because these studies are cross-sectional. They have very little risk to patients if you're not taking names, or if you're not taking patient identifiers or people's identifiers, there is no risk. So you can get ethical approval easily. You can perform them in an easy way. So it's a very good idea to try to design questionnaires. You might be able to publish, okay, in an easy and in a quick way. So first thing you do is that you set your research question, you do your literature search, you read the previous literature, then you start to consult the experts. Then if you think that you can construct a new questionnaire, of course you can use a questionnaire that's been used before, After validating it in your population, you can use it in a new population. This still is going to be a good study, but perhaps you need to design a whole new questionnaire. Of course, you read very well, you span the previous literature, you design your questionnaire, you have first to do content validation. You're going to show it to the experts. They need to comment on each item in the questionnaire. And then you are going to have another look at your questionnaire. You're going to kick out the items that are not relevant and keep the good items. Then you see how you are going to administer it. After administering it, you're going to enter it on your statistical program. Always enter your responses. You need to convert them to numbers. If you have yes or no answers, I advise you to give 0 for no, 1 for yes. And for the graded answers, you use a Likert scale and you do coding like the one you've seen on the statistical program. Then you start analyzing your questionnaire. First, you do what's called descriptive analysis. You are going to describe individual items. For each question, you're going to report whether the answers are normally distributed or not. If they are normally distributed, you have a very big sample, you are free to use the mean and the standard deviation. If your sample is not normally distributed, then you need to report the median and the quartiles, or the minimum and the maximum. Then perhaps you need to calculate subscores. It's like that caravan questionnaire. Perhaps we can make a group of information questions into a subscore. So we have a subscore from the sum or the average of the information questions. Then we have a subscore for questions about safety. Then we have a subscore for questions about spiritual aspects of the let's say the Hajj journey. So we have subscores. For these, we can report the sum of the questions or the average, and the average is better, or the mean is better, that you sum up the answers of 4 questions and you divide it by 4, so you get the mean. Okay, so what else do you do after describing your results for the individual items, for the subscores, for the scores of the whole questionnaire? If you want to sum up all the questions together and get their average, or sum them up together and report the sum. Okay, don't forget that you need to reverse the negative items, the items that ask about bad things. So if you're going to strongly agree with a bad thing or a bad aspect, you're going to reverse. Instead of 5, you give it a 1. You can do that easily on the computer. Okay. Then you need to see whether it's normally distributed data or not, to see how you're going to treat it. Then you're going to explore associations. You're going to see how questions are interrelated, how they correlate with each other. Then you are going to check for reliability, okay, by calculating your Cronbach's alpha. Then you are going to do Cronbach's alpha if item deleted, and you're going to see if all your items are relevant. Then perhaps you're going to report your results, okay, and then maybe somebody else is going to use your questionnaire on a new population and tell you the reliability with the new population. So again, these are the summary of the steps. You do literature review, you contact the experts, you do your preliminary questionnaire, you're going to do content validation, you're going to do the content validation index, then you're going to submit to the ethics committee. And then perhaps while the ethics committee is giving you the answer, you can pilot data collection and analysis, so you know what problems you might encounter. Then you're going to distribute the questionnaire, whether you're going to distribute it in paper or electronic way. Then you're going to collect data. Then you're going to do coding and reverse the negative questions. You're going to calculate your reliability, average correlations, if item deleted, analysis. Then you're going to calculate your scores and subscores, descriptive analysis and associations. And this is the summary of how to validate, how to analyze questionnaires. And any questions? Any questions? Okay. Right. I thank you very much. That was all about questionnaire validation. I hope that was useful. And good luck to you and have a nice evening. Okay. Bye bye. Oh, there's a question in the chat. Okay. Thank you. Thank you. Thank you for attending. Thank you very much. Bye bye.